Good morning, everyone. So today we're going to be learning about tests of hypothesis concerning one population mean using small samples. So we'll be using a t-test for one population mean. So let's have a review first. What are the steps in testing a hypothesis? So the first step is to state the null and alternative hypothesis, and then choose an appropriate level of significance, then establish the critical region. Third, compute for the test statistic from the sample data. Fourth, compare the computed value of the test statistic with the critical region. If the test statistic falls within the critical region, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. And lastly, we need to interpret the results with the conclusion. So for tests concerning one population, we either use a z-test or a t-test. So we use a z-test if our population standard deviation is known or the sample size is large. That is, n is greater than or equal to 30. And if the standard deviation of the population is unknown and our sample size is small, that is, n is less than 30, then we use a t-test. So for a t-test for one population mean, we have these. The null hypothesis is the mean is equal to some assumed value mu sub O. Our alternative hypothesis could be any one of these three. The mean, the population mean, is less than the assumed value, or the population mean is greater than the assumed value, or the population mean is simply not equal to the assumed value. So since we're going to use a t-test, we're going to be computing this one. T is equal to x bar minus mu sub O over S divided by square root of n. So is less than negative T of alpha for this alternative hypothesis, right? Then we're going to reject our null hypothesis. So if this is our alternative hypothesis and T is greater than T of alpha, alpha is our level of significance, by the way. So, and lastly, if you have this alternative hypothesis, mu is not equal to the assumed value, then we're going to have a two-tailed test where the critical region is found on both tails of the distribution. Then our critical region will be T is less than negative T of alpha over 2, since alpha should be divided by 2, since it will be found on both tails, or T is greater than T of alpha over 2. So to find the critical values of the student's T distribution, we need to have this table of the student's T distribution. So in the uppermost row, we have alpha. Alpha, or the level of significance, 0.1, so 10%, 0.05 is 5%, 0.025 is 2.5%, okay, 0.01, 1%, etc. And in the leftmost column, we have here the degrees of freedom, V. So other books will use DF instead of V. Okay, but this is our degrees of freedom. Okay, here we have infinity. So it means you can actually use this table for degrees of freedom greater than 29. Actually. So it means you can also use this for sample sizes larger than 30. But usually that would involve a z-test. Okay, so for t-test for one population mean, the test statistic is again this one. So x bar is the sample mean, mu sub O is the assumed population mean, S is the sample standard deviation, N is the sample size, and V is the degrees of freedom. So T is equal to the sample mean minus the assumed population mean divided by the standard deviation of the sample over the square root of the sample size. And the degrees of freedom is the sample size minus 1. So let's have an example. Test the hypothesis that the mean shelf life of a food product is 7 days. If a random sample of 25 products has an average shelf life of 6 days with a standard deviation of 0.6 days, assume that the population of shelf lives is approximately normal and use a 0.05 level of significance. Okay, let's look at the data on here. So the assumed population mean is 7 days. The sample size is 25. The sample mean is 6. The standard deviation of the sample is 0.6. And the level of significance is 0.05 or 5%. So our solution. First, we need to find the null and alternative hypothesis. So the null hypothesis, the average shelf life is 7 days. So mu is equal to 7. The alternative hypothesis is that the average shelf life is not 7 days. So in symbols, that is mu is not equal to 7 days. So this is a two-tailed test. Now, let's find our critical region. Since alpha is 0.05 and this is a two-tailed test, we need to divide alpha by 2. So we have alpha over 2 is 0.025. And since the sample size is 25, our degrees of freedom is 24. So we need to find the intersection between 0.025 and 24. Okay, so we have our critical value to be 2.064. But this is not our critical region. This is only our critical value from the table. So what is our critical region? So this is our critical region. So here is negative 2.064. So this is the boundary of our critical region on the left side, and the boundary of the critical region on the right side is 2.064. So if our computed value or the test statistic is less than negative 2.064, or if the computed value of the test statistic is greater than 2.064, we are going to reject our null hypothesis since the test statistic will be in our critical region. So this is so far what we've got. Okay, so the null and alternative hypothesis done. For our critical region, it's t is less than negative 2.064 or t is greater than 2.064. And here is our illustration. Okay, so we need now to compute for our test statistic. Okay, so you remember the formula. T is equal to x bar minus mu sub O over S divided by square root of N. So again, the sample mean is 6. The assumed population mean is 7. The standard deviation of the sample is 0.6. And the sample size is 25. So substituting our values in this formula, we have t is equal to negative 8.33. So is it found in the critical region? Well, yes. So obviously, it's less than negative 2.064. So it's found somewhere here. So it's in the critical region. So for our decision, we reject our null hypothesis. And after this, we need to have a conclusion. So since we rejected the null hypothesis, then there is sufficient evidence to show that the average shelf life is significantly not 7 days. Okay? Okay, there's sufficient evidence to show that the average shelf life of the food product is not 7 days. Okay? Or is not significantly equal to 7 days. Okay, let's have another example. So test the hypothesis that the average content of a juice drink is significantly less than 500 ml. If 16 bottles of juice had an average content of 497 ml with a standard deviation of 5 ml. So we're going to use a 0.01 level of significance and assume that the population of drinks is normally distributed. Okay. So the data, the assumed population mean or the average content of juice drink is 500 ml. Okay. We use 16 bottles, so our sample size is 16. So the sample mean or sample average content is 497 ml. And the standard deviation of this sample is 5 ml. So we're going to use alpha is equal to 0.01. So this is our level of significance. Now, our solution. So the null and alternative hypothesis are these. The average content of the juice drink is 500 ml for our null hypothesis. So in symbols, this is mu is equal to 500 ml. And our alternative hypothesis, the average content of a juice drink is significantly less than 500 ml. So in symbols, that is mu is less than 500 ml. So this is a one-tailed test. So there's no need for us to divide the level of significance by 2, since this is a one-tailed test. Okay, now let's find the critical region. So alpha is 0.01. Okay, and n is 16. So the degrees of freedom is 15. So we get the intersection between 0.01 and 15, and that is 2.602. This is our critical region. Since our critical value, since our alternative hypothesis states that the mean is less than 500 ml, less than. So our critical region is found on the left side of the distribution. Okay, so we need to put a negative sign here. So this is our boundary, negative 2.062, and our critical region is t is less than negative 2.0602. Mean 2.602. Now we have these. The null hypothesis, the average content of a juice drink is 500 ml. Alternative hypothesis, the average content of a juice drink is significantly less than 500 ml. Our level of significance is alpha is equal to 0.01. So our critical region is t is less than negative 2.602. And our test statistic is 497 minus 500 divided by 5 over square root of 16. So t is negative 2.4. Okay, so since this is not less than negative 2.602, then we do not reject the null hypothesis. And we conclude that there is insufficient evidence to show that the average content of a juice drink is significantly less than 500 ml. Okay, so the difference of 3, I mean, the difference of 3 is not yet significant. 3 ml. It's not yet significant. Okay? So you can do this. these exercises. Okay. And next time, we can test hypothesis for more than one population. Okay. So goodbye. God bless and stay safe.